Hello Mr. Chu. Before we present our video, I would like to introduce you our group members. I'm Herbert Liu.
Hi, I'm Amy.
Hi, I'm Clement.
Hi, I'm Bhavesh Parag.
Hi, I'm Zitman.
Hi, I'm Gregory. Check out our video.
For our case study, we choose our Taylor's University as it was assembled using the IBS components such as the hollow floor slab. That is, no need to use reinforcement, but only the use of tenant is required. Precast beam and columns and staircase are used. The components has been manufactured off-site and transported to Taylor's University to assemble. The only task that the worker has to do was to assemble the component to make the structure efficiently. This system has reduced the wastage construction, it speed up the construction time, no need skilled workers, and has improved the construction quality and productivity. This system has lowered the total construction costs in terms of labor, materials, and wastage. The engineers have designed this building to be anti-earthquake, and the life expectancy is up to 100 years by using these precast components. Even by using precast components, the services required in this building has been successfully installed in the corridor ceiling, such as electrical wirings, water pipes, air conditioning pipes, and fire protection system like sprinkles are all fixed to the ceiling. Even in the classroom, 3/4 of the space has been used for ceiling purposes to hide the services and add aesthetic values to the room. The Malaysian government has been encouraging the industrialization of the Malaysian construction industry with different technique and construction. According to CIDP IBS survey, less than 1/3 of the completed project in Malaysia has utilized the IBS method.
Does it sound familiar? Heavy equipment, conventional forming using plywood and timber, large number of skilled workers needed, environmental unfriendly, untidy work site, dimensional accuracy compromised, the price too clear.
Audio Jungle. Audio Jungle. Audio Jungle.
This is the process of precast concrete. The process starts with engineering. Every product is engineered using the latest tools, and detailed drawings are created using the 3D computer-aided design process. Once the design drawings are approved, they are sent to the factory floor and used to monitor the production. Now it's the time to assemble the rebar cage. The first step of this process is cutting and bending of the steel reinforcement. The correct rebar is selected and shaken down off the storage rack. It is then cut and bent to the exact dimensions needed to fit the design requirements. Next, the bars are assembled and tied together to form the reinforcement cage. Rebar wheelchairs are used to help the position of the cage within the form and ensure proper clearance reinforcing. Once the cage assembly is complete, preparation and cleaning of the form will begin. A foam release is applied to each surface to ensure the final product can be easily lifted from the form. When the form is ready, the overhead crane will pick and place the cage onto the core of the form. Once the setup is complete, a certified quality control technician will conduct a pre-pour inspection. After satisfactory completion of this inspection, the workers will start the concrete placement process. The raw material used for the concrete are cement, coarse aggregate, sand, and chemical admixtures. They are carefully selected and mixed according to the specific requirements. Normally, every precast concrete factory has a concrete laboratory used to conduct routine raw material testing and control exact quantities for each batch. Once the materials are properly mixed, the self-consolidating concrete will undergo a variety of tests to ensure it is of required quality. The approved batch is transported in a bucket via an overhead crane to the product form. Concrete is placed into the form and care is taken to allow the concrete to flow without entrapping air voids. Once the form is filled, the top of the form is screeded off and the specified finish is applied. Once the concrete is placed, the curing process begins. This may include topping the product overnight in order to capture the heat from the hydration process. The controlled environment of the precast factory enables the products properly cures and reach the full design strength. Once the technician confirms that the product has reached the desired strength, the product may be removed from the form by lifting the devices. Once the product has been removed, it is then cleaned and a post-pour inspection is conducted. If all design dimensions have been maintained and no visual defects are noted, the final product is then labeled and transported and stored into the yard. When the customer is ready to receive the order, the product is loaded on a truck and properly tied down for shipment and delivered to the project site.
Hello guys, now I would like to tell you guys how the precast concrete forms a building. The precast components can be connected in few ways. One of the way is fall slab to beam. When the hollow core slabs sent to the site, They are lifting up by a mobile crane with a lifting beam, top lift clamps with sliding shackles and accessories safety chain from the delivery truck. After lifting up the hollow core slab, it is placed on the required position, and do remember that the accessories safety chain should not be taken until it reaches the final erected position. The worker on the site place and arrange the hollow core slab carefully to the correct position. When the whole 4 slabs have been positioned to the correct place on the beam, they started to a ground mix which named E-mix grout with reinforcement bars. When the E-mix grout is dry, the top of the precast slab and supporting beam is topped by 75 mm of structural concrete topping. One layer of BRC mesh is placed on the slab. After the BRC mesh is topped on the slab, they started to pour the concrete on top of the slab with BRC mesh, and one floor work is done.
Precast columns are installed by hoisting at the lifting hook provided at the top of the column. After the precast columns have been surveyed and aligned, it shall be in grouted sleeves connections, which is by the method of grouting the bar projecting from lower column or foundation into corrugated sleeves cast in the precast columns. Before the grouts have sufficient strength, the props shall not be disturbed or removed. The columns shall be held vertically during construction by push-pull props rigidly secured to the pre-stressed beam. A steel bar is then inserted into the hollow core section of the panels to lift the panel onto that machine. Before installation, Aquafix will be applied to the bottom and side of the specific areas of the wall panels. So, this is the wall panels that is being transported using delivery trucks. A crane is then used to transfer the panels to the desired floor levels. Here we can see that steel bars are inserted into the hollow core section of the panels so that it is easier to lift the wall panels onto that machine. During the erection process, 2 to 3 manpower is enough to erect each panel upright and also to align them. The workers then fix a wooden wedge to the access space of the top end of the wall. This is to make sure that the wall panels are upright and stays that way until cement mortar is filled in. Aquafix will again be applied to the wall panels gap to ensure water tightness. Here we can compare the speed of constructing the wall using precast wall panels as compared to using blocks. A hole is then made on the wall for wiring purposes.
Hi sir, I'm going to talk about the advantages and disadvantages of precast concrete. The advantages of precast concrete. The concrete of superior quality is produced as it is possible to have better technical control on the production of concrete in factory. For example, the environment temperature in factory can be controlled during the curing of concrete. The labor required in the manufacturing process of the precast units can easily be trained comparing on-site. The molds employed for preparing the precast unit are of steel with exact dimension in all directions. These molds are more durable and they can be used several times.
The precast structure can be dismantled when required and they can then be suitably used elsewhere. The project that use precast can be completed in a short time. When precast structures are to be installed, it is evident that the amount of scaffolding and formwork is considerably reduced. The disadvantages of precast concrete. If the precast is not properly handled, the precast units may be damaged during transport, and it is necessary to arrange for special equipment for lifting and moving of the precast unit. The economy achieved in precast construction is partially balanced by the amount to be spent in transport and handling of precast members. It becomes therefore necessary to locate the precast factory at such a place that transport and handling charges are brought down to the minimum possible extent.